They're asking us to solve triangle ABC. Side A is 9.47. Side B is 15.9, and side C is 21.1 feet. Okay, so let's go ahead and draw. Alright, so this looks like the longer of the three sides. I'm going to call this side C with 21.1 feet. That means that opposite to that side will be angle C. This one looks like the second largest, so I'm going to make this side B with 15.9 feet. And that means that opposite to that we'll have angle B. And finally this will be 9.47 feet. And opposite to that will be angle A. Alright, so because the three sides are given but no information about the angles, this is a case of side, side, side. Which means we are still, we can still use the law of cosines to help us find the missing information. So what is missing? Well, we're missing angle A, angle B, and angle C. So again, I'm going to give you some guidelines for the steps. Step 1, you want to use the law of cosines to help you find the largest angle. So which of these angles is the largest angle, and how do you know?
Angle C.
Good, yeah. And what's the reason?
It has the largest side.
Good, it corresponds to the largest side. Very good. Okay, so in order to be able to find angle C, I need to take a look at the law of cosines and see which of the three formulas has angle C. Well, that would be this last one. So this is the one that we're going to use. And we're going to use C squared is equal to A squared plus B squared minus 2AB times cosine of angle C. And before we plug in any of the values, we can try to solve for angle C as much as possible. So that means I can subtract A squared from both sides and B squared from both sides of the equation to get C squared minus A squared minus B squared equals negative 2AB times cosine of angle C. Give me 1 second, guys. Okay. And then from there, remember our goal is still to find angle C, so I need to isolate it. That means I can divide both sides by the negative 2AB, and that's going to give us that cosine of angle C is equal to C squared minus A squared minus B squared divided by negative 2AB. And finally, if you have cosine of an angle with the known value, and we do know that value, or we are going to be able to calculate it because all of this information is given, all of those sides are given, then I can take cosine inverse. So C is going to be cosine inverse of this information. So let's actually plug it in at this point. We said we have C squared. Maybe I'll take up 2 lines, that way it doesn't get too messy. So C squared would be a 21.1 squared. Oh, well, maybe not that line. I'm going to run into the other. Okay, so 21.1 squared minus A squared, so that would be minus 9.47 squared minus B squared, that is 15.9 squared. And then divided by -2 times A, which is 9.47, times B, which is 15.9. Okay. And let's see what that gives us. We're going to get cosine inverse of, actually I think I punched the wrong button. Okay, so cosine inverse of, I have to be very careful here because I do have these subtractions happening in the numerator. So I'm going to encompass the numerator in parentheses. 21.1 squared minus a 9.47 squared minus a 15.9 squared. Okay, and then close the parentheses to close the numerator, divided by, I'm going to open parentheses to encompass the denominator, a -2 times 9.47 times a 15.9. Okay, so now I'm closing the denominator and then closing the cosine inverse, and that gives me approximately 110 degrees. Okay, I'm going to round to the nearest whole degrees. Okay, so approximately 110 degrees. So notice for cosine inverse, the calculator does return to us an obtuse angle. It can return to us an obtuse angle. That is not the case for sine. Okay, for sine inverse, it just returns the reference angle, but here it actually returns to us the real angle. Okay, so that's C. The next step is to now use the law of sines to find any of the two missing angles. So we're missing A and B. Doesn't matter which one you pick at this point, because if C is obtuse, it will show up. And since we picked the largest angle, the remaining two are going to have to be acute. So it doesn't matter which one you pick. I'll just start with A. Okay, I'll have sine of angle A over side A, which is 9.47, is equal to the only angle and side pair that I can use right now is angle C and side C, because that's the angle that I know, right? I don't know A and I don't know B. So I'm just going to use sine of angle C, which is 110 over side C, which is 21.1 feet. So now multiply both sides by 9.47. These are going to cancel. Now we're going to have sine of A is equal to a 9.47 times sine of 110 degrees divided by 21.1. Which means, again, if we want to find A, we're going to have to take sine inverse. So A is going to be sine inverse of this information here. So now we punch it in. Sine inverse of 9.47 times sine of 110 degrees divided by 21.1. We get approximately 25 degrees. So again, we have just one angle left to find, that's angle B. And at this point, since we have both C and A, we can use triangle angle sum theorem to help us find that last angle. So step 3, use A plus B plus C, which is triangle angle sum theorem equals 180 to find the missing angle. I'm running out of space, so I'm going to write it on a sticky note. I have A plus B plus C equals 180. So that means that B is going to be equal to 180 minus angle A, which is 25. We found it here. Oh, sorry, that's not coming out. Okay. And then minus angle C, which is 110. Yeah, so that's a 180 minus 135. So B is going to be 45 degrees.
Professor, would you please show me how you input the step 1 equation into the calculator? I'm not getting 110.
Yeah, give me 1 second. So it looks like this, but I can enter it again. What you want to double check, because usually the common mistake that happens when inputting this type of problem is that you don't have a parenthesis around the numerator. So just make sure that you have cosine inverse open parenthesis, that's for the cosine. Then we'll have another open parenthesis, which means the beginning of the numerator. So 21.1 squared minus 9.47 squared minus 15.9 squared. At that point, you want to close the numerator and then have divided by, and then again, I have an open parenthesis for the denominator, the negative 2 times 9.47 times 15.9. I'm closing the denominator, and then finally I close the cosine inverse.
Oh, perfect. Thank you. It was the denominator that was messing me up.
Oh, okay. Yeah. All right, so the last thing that we're going to consider is using trigonometric formulas for the area of a triangle. And perhaps the formula that we're more commonly used to is area equals 1/2 the base times the height. But we're now going to take a look at 3 formulas that also allow us to find the area based on 1 given angle and 2 given sides. Okay, so just to draw one possible case where we can apply these formulas, we have triangle ABC with side A, side B, side C. Let's suppose that they gave us information about angle A, side B, and side C. Then in that case, we would have enough information to find the area of the triangle based on this first version of the formula. If you notice, for any of the other 2 versions, we're going to be having a side angle side type of situation in terms of the information that is given. For example, if we take a look at area is equal to 1/2 A times C times sine of B, that means that we're given angle B, we're given side A, and we're given side C. So again, that would be a side angle side situation. So let's apply it with this next example. Find the area of triangle ABC if angle B is 55 degrees, 10 minutes, side A is 34 feet, and side C is 42 feet. For this problem, we're going to be using the second version of the formula because we are given angle B in both side A and side C. So it's a plug and chug type of problem. The area will be 1/2 times A, that's 34 feet, times C, that's 42, times sine of the angle, 55 degrees, 10 minutes. So we'll go ahead and punch it into our calculator. We've got 0.5 for the 1/2 times 34 times 42 times sine of 55 degrees, 10 minutes. That results in an answer of approximately 586. We're going to be rounding to the nearest tenth of a square foot, so that would be about 0.1 square feet. All right, so that marks the end of our section 3, unit 2. And in fact, it marks the end of unit 2. So this would be the last piece of information that you would need to keep in mind for this week's exam number 2.